So this was a structure pop quiz related to alcohols and halogenoalkanes. So if you have a doubt in question one, any doubt in question one? So what happened? These reactions are substitution reactions. What happened in substitution reaction? Name the type and the mechanism of these reaction. When halogenoalkanes are reacting with the reagents, other reagents, the reactions are SN reactions, nucleophilic substitution reaction. So what is a type and what is a mechanism? The type can be like a substitution reaction is there, or and mechanism, how the reaction proceed, it is a nucleophile. So it is a nucleophilic substitution reaction. Type of a reaction might be substitution, addition, elimination. So this is substitution. And what is the mechanism for halogenoalkane? The mechanism is always a nucleophilic reaction. So they always have a nucleophilic reaction. In this case, how it is reacted, it means it is reacted with ammonia. Because when ammonia, NH2 will displace, mechanism can be a free radical, mechanism can be a electrophilic, mechanism can be a nucleophilic. And the types are addition, substitution, elimination. These are the types of the reaction. So if you write nucleophilic substitution reaction, that's also fine. Because that is the order according to the question. For those who just joined now, this is a structure pop quiz 12 related to topic alcohols and halogenoalkanes. So for this reaction, it will be reacted with ammonia. What about the second reaction? So here what we use KOH, potassium hydroxide. And what is the potassium hydroxide? It is aqueous potassium hydroxide. And here the KCN in the presence of ethanol. So what will happen? Again, there will be a substitution reaction happen or occur, and it will result in a formation of a nitrile group. So how the reaction will proceed? The CN group will displace this Br. So what is the product? The product will be H3C, CH3, CN, and then CH3. So how we name this compound? We select the longest carbon chain. So when we select the longest carbon chain, like this is the longest carbon chain, and these two are the branches. So we have two branches. What will the name of this compound? 2,2-dimethyl, because two methyl branches are there, and three carbon atoms are there. So we call prop. They have a single bond N, and due to the CN, we call nitrile. So this is 2,2-dimethyl propane nitrile. That's the name of this compound. You have to learn the reaction conditions for each reaction. When a halogenoalkane, it reacted with ammonia, it will form amine. When halogenoalkane reacted with potassium hydroxide or when halogenoalkane reacted with potassium hydroxide or sodium hydroxide in aqueous medium, this will form an alcohol. And when halogenoalkane reacted with a mixture of potassium cyanide and hydrogen cyanide in alcoholic medium, it will also result in a formation of substitution reaction. So all of these reactions are the substitution reaction. So give ioptic name of the and the structure of a compound M. So we just drew that and named as state the reagent and the condition required for reaction 1. As I mentioned, you have to learn these reaction conditions whenever we want to convert the halogen-alkane into amine. So what are the reaction conditions? We will use ammonia here, and it should be an alcoholic solution. So the reagent, the chemical which we use ammonia under a very high pressure, and it is alcoholic solution. Like the medium, like we'll say ammonia and ethanol. Here we wrote KCN in ethanol. Here we'll say ammonia and ethanol for the conversion of a halogen alkane into amine. These are the reaction conditions which you have to learn. The next is an incomplete mechanism for the reaction. For a reaction 2 is shown. Like this is incomplete mechanism. This is SN2 reaction. Why it is SN2 reaction? It's a tertiary halogen alkanes. Tertiary halogen alkanes undergo SN2 reaction. So in a tertiary halogen alkane, first the bond breaking will happen, and then the bond forming will occur. So first the bond will break, and then the attacking nucleophile, the OH, will attack on this, and as a result, the reaction will proceed. The question is, complete the mechanism by adding a curly arrows and a relevant dipoles on the lone pairs. So we have to show the curly arrows because if it's a homolytic bond breaking, then it will be a half arrow. It's a heterolytic bond breaking, then it will be a full arrow. So first, when you see the halogen alkane, the partial positive will be there on the carbon and the partial negative will be there on bromine. And the bromine is taking both of these electrons, so the full arrow will be there towards the bromine. That's the first thing. Then what happened? The OH is there, so OH will have a lone pair. And this lone pair, we start the arrow from where the electrons start and where it ends. So these lone pair on the OH it's forming a bond with the carbon. So we'll draw an arrow here. That's we have to do. Describe how intermediate J is formed in the first step and name the process that occur. So how this J is formed, as you can see, it's a heterolytic bond breaking. So describe how J is formed. So how this intermediate J is formed? It is formed by heterolytic bond breaking. And what happened in a heterolytic bond breaking? The electron pair between the carbon and bromine is transferred to bromine. So the bromine take both of these electrons which are involved in the bonding. That's why we got this positive charge and a negative charge. So that we have to explain. State the shape of intermediate J. How to determine the shape? To determine the shape, you have to check the central atom. So how many bonds pair you see? If you see the number of the bond pair, it is bonded with CH3. So 3 bond pairs are there and there is no lone pair because the carbon has already lost that electron. So 1 bond pair, 2 bond pair, 3 bond pair. So what will the shape of the structure which is having 3 bond pair and there's no lone pair. So what is the shape? It will be trigonal planar. So trigonal planar will be the shape, and the reason you will mention that because it has three bond pair and no lone pair. So the atoms will always try to arrange themselves to minimize the repulsion. So state the shape of intermediate and justify your answer. So what will the shape? The shape will be trigonal planar, and justification because it has three bond pairs and no lone pair. So the atoms will have a minimum repulsion when they are arranged at an angle of 120, or the structure or geometry will be trigonal planar. The product of a reaction 2 is shown. Like this is the product of a reaction 2. This compound has three isomers that are also alcohol. So this is which alcohol is drawn. This is the tertiary alcohol is drawn. So we want to draw a structure of these isomers. So what we can do, we can draw a primary, you can draw secondary, and we can also draw a branch alcohol as well. That is what we can do. And we have to draw the structures. They did not mention which structure we have to draw. It can be a skeletal formula. It can be a displayed formula as well. So we have CH3. Like first I will draw the primary alcohol, CH3, CH2, CH2, and OH. This is the first. I drew a primary. Then I will draw a secondary alcohol, or even I can draw another primary but with a branch. So this is also a primary. This is also a primary, but it is a branched. And I can now draw the tertiary, secondary. This is already tertiary. So if I want to draw secondary, I will just, the carbon which is attached with OH, it is having two alkyl groups. So this will be CH2 and then CH3. So this is a secondary. How it's secondary? Because two carbon chains are attached. And this is a primary because the CH2 is attached. So two hydrogens are there. Like the carbon which is attached with OH is having only one carbon chain around it. And here also, this is also primary. So these two are primary. This one is secondary. But this is a straight chain, like OH is there. And this one, I drew a branch one. Even I can change the position of OH as well. Like I can just change the position of OH. That will also be fine. Yeah, there are more isomers. We can change the position of OH as well. Like here I do butane 1-ol. I can draw butane 2-ol as well. The next is the reaction of a alkane with a hydroxide ion is often carried out sodium hydroxide or potassium hydroxide. An alternative is a moist silver 1 oxide is there. So the reaction of a halogenoalkane with hydroxide with the same, yeah, you can place anywhere, but it should have a same molecular formula. You can place carbon and hydroxide anywhere, just the structure should be different. That is the main idea of drawing the isomers. So halogenoalkane with hydroxide ion is often carried out using a sodium hydroxide or a potassium hydroxide. An alternative is the moist silver 1 oxide, which is prepared by adding a few drops of a water to a solid silver 1 oxide. Silver 1 oxide is insoluble in water but produces sufficient hydroxide ions for the reaction. Write an ionic equation for a reaction of a silver 1 oxide with water. So using the information, you just have to complete a balance equation. As you can see, silver 1 oxide is mixed with water. It is forming a silver and a hydroxide ions. And the equation must be balanced as it's few drops of water into silver 1 oxide, and silver 1 oxide is insoluble. So if we have a silver 1 oxide, what will the formula for a silver 1 oxide? Silver has a valency of +1 and oxygen is -2. So silver 1 oxide will be Ag2O. So this will be silver 1 oxide. It is mixed with water. So what is the formula for water? We have to write ionic equation. I will write the ionic equation first. I am writing a full equation. So when it dissolves, it produces silver 1 hydroxide. So it will form AgOH. It will form AgOH because silver is +1 and hydroxide is -1. And the equation must be balanced. So if you put 2, so this whole equation is balanced because oxygen 2, hydrogen 2, silver also 2. The state symbol, this is solid, water is a liquid, and this will be aqueous. How we know this is aqueous, the silver 1 hydroxide? Because they mentioned produces sufficient amount of hydroxide ion. So it means it is producing hydroxide ion, and that is yeah, as they said, ionic equation. This is a complete equation. This is not the answer here, but the question is write an ionic equation. So if we need an ionic equation, what we will do? We'll just break down into ions, because in an ionic equation, solid, liquid, and gas we write as it is. So I cannot change silver oxide or I cannot change water. This is the aqueous substance that I will only break down into ion. So what will the equation? The equation will be Ag2O plus water will form silver ion. How many? Two of them, and it will form 2 hydroxide ion. That's it. This will be aqueous. This will be aqueous. This is liquid, and this one is solid. Is it clear? This ionic equation? So this is the answer. You are not supposed to write AgOH to AgOH because that means it is an overall equation. But in ionic equation, we represent the ions which are dissolved in aqueous form. So separately. If there was a common ions, we cancel out them. Suggest one advantage of using a silver 1 oxide rather than sodium hydroxide or a potassium hydroxide. So as you can see, sodium hydroxide and potassium hydroxide are soluble already. But what will happen if we are using, say we were preparing potassium hydroxide, we have potassium oxide. The moment we add potassium oxide, it will dissociate and form potassium ion and the hydroxide ion, a solution of potassium hydroxide. The more you add, the more it will dissolve, because potassium hydroxide is water soluble, or potassium oxide is also water soluble, or sodium oxide is also water soluble. Or if you use the pellets of a sodium hydroxide and potassium hydroxide, it is solid at room temperature and it can dissolve when you add into water. So the how much you add, the all will dissolve. But what is the advantage of using a silver 1 oxide? That when the silver 1 oxide is insoluble, they mention in the question. So when the silver 1 oxide is insoluble, so when you add, it will break down, like it will react and form a silver ion and the hydroxide ion. But the one which does not react will remain insoluble. So you can separate the unreacted silver 1 oxide by filtration. So one advantage of using a silver 1 oxide rather than sodium or a potassium hydroxide, that as you can see, silver 1 oxide is insoluble. So the unreacted silver 1 oxide can be removed by filtration. But the unreacted potassium or a sodium hydroxide cannot be removed by filtration because it is a soluble, or it will dissolve instantly. In question 2, which of these bromoalkanes may be classified as tertiary? So how we classify as tertiary? The carbon is attached with halogen. How many are there? We check the number of the carbon chain, the carbon attached with the halogen, number of the carbon chains. So this is classified as one carbon chain, and this whole is classified as second carbon chain. So two carbon chains. Here's a carbon attached. It is having only one carbon chain, so it's primary. Here is a carbon attached with a halogen, one carbon chain, two carbon chain, and three carbon chains. So mean this is a tertiary. So this one is a primary, this is a tertiary, and this one is a secondary. So which one of them is classified as tertiary? So only R can be classified as tertiary. When 1-chlorobutane is mixed with ethanol and aqueous silver nitrate, a reaction occurs. Which species is a nucleophile in this reaction? So when we have 1-chlorobutane, we draw the structure. First position, a chlorine is attached. This will have hydrogen. This will be CH2, this will be CH2, and this will be CH3. The carbon will be partial positive, chlorine will be partial negative. This is a primary halogenoalkane, as you can see. So in a primary halogenoalkane, the SN2 reaction occur that the attacking nucleophile can attack at the same time. The bond breaking and bond forming will take place at the same time. So what is the attacking nucleophile here? Which species in this reaction is a nucleophile? As a silver nitrate is there, 1-chlorobutane is mixed with ethanol and then aqueous silver nitrate. So the aqueous silver nitrate contain a silver ion and the nitrate ion. The nitrate ion is not attacking on this. Carbon is partial positive. Ethanol contains C2H5OH. Nitrate ion is NO3, but it is not forming result. Result solution is not a nitrate ion attached to a carbon. Result solution is actually an alcohol. The silver ions are also not attacking. So what is nucleophile here? Which species? Which species is a nucleophile? So actually, because the water contain H2O, the water will dissociate into H plus ion and OH minus ion. So the OH ions, the hydroxide ions, which are there and they are having a lone pair, they will attack on the carbon. So actually the OH ion are produced by the water. That's why we say the species, the nucleophile in this reaction is water or H2O. Is it clear? Why alcohol cannot be a nucleophile here, even though alcohol also contain OH. But the thing is that the alcohol is C2H5OH. But this OH does not break the bond. There's no bond breaking in the alcohol. What actually happen is water contain the lone pair. One part of it is partial negative and one is partial positive. And this negative part will attack on the carbon which is partial positive. That's why the water is even though the ethanol contained OH, but that OH is not breaking the bond. The OH of the water is breaking the bond and turn into alcohol. That's why the attacking nucleophile is the species which is providing this nucleophile is water rather than alcohol. For these reactions, you have to learn the conditions. The next is propane 1-ol. Propane 1-ol may be converted into propene. Which reagent is used for this reaction? This is the elimination reaction. As you can see, an alcohol is there, it converted into alkene and water. So if an alcohol is converted into alkene and water for an elimination reaction, again, the reaction conditions you have to use. So 50% what is the reaction condition? What we use for elimination reaction of alcohol to convert them into alkene? We use phosphoric 5 acid. So phosphoric 5 acid is used in these reactions whenever you want to convert alcohol into alkene. And if you want to convert alkene into alcohol, you react it with steam. That is a reverse reaction. So for reverse reaction, we need steam. But for forward reaction, what we need phosphoric 5 acid. The reaction is best classified as, what is a description of this reaction? Whenever, as you can see, a small molecule is released from a substance, what we call that as elimination reaction. If it was a hydrolysis, how we know it's a hydrolysis? If it was a hydrolysis, water should be the reactant. If it was a reduction, there should be change in oxidation number, but when we write the oxidation number of each, there will be no change in oxidation number. If it was a substitution, atom or a group of atom replaces another atom or group. Like if it was CCl was there, and it will reacting with, like, let's say OH. OH will take position of Cl and Cl will go out. This will be a substitution reaction. So this is elimination reaction which occurs.